Hey folks, welcome to our second video on business intelligence. I'm Dan Schreck from Viam. In our first video on modern business intelligence, we went over some good BI practices, some poor BI practices, and why business intelligence matters in the first place, and perhaps why it matters even more today than ever. Then we discussed what's driving market changes, particularly with the rapidly increasing amount of data required to report and analyze business data in today's world. If you haven't watched that video, I highly suggest you start there. Hey, it's just 12 minutes of your life. In this video on cloud data management for BI, we'll cover many of the basics of data management, but we'll focus on how cloud-based data warehouses, data lakes, and other tools are creating huge transformative changes in BI. We're talking moving, storing, managing metadata and data quality using these cloud-based systems. Then in the next video, we'll move on to talk about visualization for BI. Now, before getting started at Viam, we specialize in HR and people, business intelligence and analytics, all the data management and integration that goes with that, as well as working and consulting on related HR and human capital management applications. So we may occasionally discuss BI in the context of HR, but you'll find these videos applicable to all areas of business intelligence, sales, finance, marketing, etc. Are you ready? Let's go. We define data management as the storing, moving, securing, managing metadata and data quality. And of course, that visualization as the presentation or the rendering of that data, which as we said, we'll cover in the next video. Now, with everything to consider regarding data management, it's not surprising that it accounts for upwards of 80% of the time spent on BI projects, at least initially. In more mature projects, yeah, that number may drop, but there is still a significant amount of time spent discovering what data to use, migrating that data to a place to use it, cleaning and transforming that data to a usable condition, modeling, securing, and other aspects of managing data. So a seemingly simple request for a new analytic, report, or even a new data point, an existing one, might require a lot of steps just to prepare and manage the data before it's ever used. You might then assume anything that reduces the time and effort spent on data management may have the largest impact on BI. With the goal of increasing overall BI return on investment, we'll attempt to show how the more modern data lakehouses reduce hardware and IT costs, how integration tools with embedded data catalogs handle a more convoluted data environment, and how all this can result in faster BI time to value and potentially better decision making. First, let's go over data lakes and warehouses. For much, but not all of BI, the end result of all this data engineering, data management, is a data warehouse or data lake or maybe data mart. And that's what the data scientists, the developers, the analysts, and just users use to do their analysis, their analytics, their dashboards and reports. So let's take a quick look at those. Of course, there's going to be some differences between all data warehouses, but any data warehouse, you're going to have your data sources, your HR, your ERP, your CRM. There may be some flat files from those or other data sources, APIs. And of course, these are going to flow into a staging environment in your data warehouse. You're going to be extracting that data from those systems, transforming it, and loading it into staging. Then from your staging course, we're going to go into your enterprise data warehouse, right? And it has its model, which defines its structure. And of course, you may have some additional transformations. Now, then it goes into your data marts, right? These may be finance, marketing, be HR, etc. And they have their own models. And of course, there may be some additional transformation from your data warehouse. And finally, we have your users, your developers, your analysts, employees. They're building analytics, reports, doing data mining with all these data marts. So it's important to note that because of these predefined models or schemas, we have to do the transformation before we load it. And we call this schema on write. So in contrast to those old stuffy data warehouses, data lakes evolved not too long ago. Now they contain all kinds of data. You may still have your ERP, but you may also have social media data, IoT data, often very fast changing data, because it ends up being extracted out of those systems, loaded in as raw data into your data lake. And because there's no schema, you can load that data very quickly. Once that data is in the data lake, you may have a need for IoT dashboard, let's say. So you'd create a data model and create that dashboard. Or marketing analytics. You create another model, create those analytics. Some data research, etc. What you're doing is doing the transformation near the end, and we call that a schema on read. Many of these systems work wonderfully. There are some challenges. Traditional data warehouses must balance cost versus performance, meaning users often have to occasionally tolerate poor performance from undersized and heavily utilized systems. And potentially addressing those performance issues comes at a cost of skilled engineers bringing new resources online, which may in turn not be utilized often enough. Now, this is a result of on-premise or even some basic cloud versions not being built to be able to scale. Second, less agility in data warehouses is a result of their predefined, often complex models, which in turn require more integration work. In fact, the ETL process often puts a strain on the end-to-end system when it requires data source to perform the required transformations. This results in slower than desired change management process. In other words, it takes longer to institute desired changes in your data warehouse. This inability to change and adapt and be more agile also reduces the creativity of your data consumers. Okay, so what's new? Well, just in the past few years, these cloud-based data warehouse as a service, DWaaS, are shaking things up much like SaaS applications did a decade or more before, where you had HR and ERP and CRM applications on premise. Now, rather quickly, they all disappeared and everything's cloud-based. Same thing's happening with traditional data warehouses, data lakes, becoming cloud-based. So these newer data warehouses solve the challenge of balancing cost versus performance in slightly different ways. First, relational databases used by some data warehouses and nearly all transactional applications. Those transactional applications being your ERP systems, CRMs, payroll, all the normal applications used in business. All those really use row-based storage. In contrast, all the modern data warehouses are columnar data stores. They store data in columns, not rows. And this drastically improves the performance of many analytic and data-intensive operations. Second, all of these modern cloud-based systems have some sort of mechanism for scaling resources to meet performance needs. Either vertically scaling by adding more CPU cores and memory, or horizontally scaling by adding more clustered machines. Both aspects really improve BI performance. There's a lot of other similarities like languages and frameworks they support, SQL, Spark, Python, R, etc. But of course, there are differences. You have Amazon Redshift that's been out for quite a while, so perhaps not surprisingly, it's a bit more of a traditional data warehouse. The same with Azure Synapse, which is a rebranding of Microsoft's SQL data warehouse. Now, these two tend to require engineers to spend more time maintaining and tuning it. For this reason, it may be best applied to use cases where you have more constant workload or a larger enterprise with the necessary staff. On the other side of the spectrum, you have Google's BigQuery, a serverless data warehouse, where maintenance is nearly non-existent. You don't have to tune, you pick sizes, you don't have to pick sizes of servers. It just handles scaling with massively parallel processing. Now, part of the magic that allows this is BigQuery separates resources required by compute from storage resources. In other words, the memory and CPU power used by running queries and other computations is separate from the actual storage of the data. This can often be the lowest cost option, especially if you have intermittent and very resource intensive operations. Finally, Snowflake can be viewed as being between the two extremes. Like BigQuery, it separates the resources required by storage of data from the resources required for computing. So it can scale compute resources vertically and horizontally in a snap, and it's somewhere between Redshift or Synapse and BigQuery in maintenance and control. For instance, Snowflake, you can control your data warehouse size from extra small through medium and extra large. Generally, this is to improve query performance. But you can also, Snowflake also allows you to create multiple clusters to better handle concurrency meaning either multiple concurrent queries or users. These options provide a bit more flexibility, which, at the cost of slightly more administration than BigQuery. These cloud systems are capable enough to act as a data lake or data warehouse, so I like to refer to them as data lakehouses. So let's erase all the traditional data lake stuff and discuss what the heck is a data lakehouse anyway. Now, like a normal data lake, you still have the same data sources moving all sorts of raw data into the lake, flat files, IoT data, social media posts, whatever. Then you still have your separate models and schemas for an IoT dashboard, marketing research, analytics, whatever kind of analytics or reports you may want to use using that schema on read method. Okay, then you can have your enterprise data warehouse pull some subset of data from your data lakehouse, and you can set up separate data marts for HR, financing, marketing, etc., as you normally would. Okay, so you may be thinking, I can pretty much do the same thing with traditional data lake and data warehouse, right? Well, here's the thing. With the newer built for cloud data lakehouse, maintenance and administration tasks are much, much easier. For instance, with a few clicks of a button, you can copy your EDW and create a new virtual data warehouse, perhaps adding some kind of required data down the road to it, and develop a slightly different data mart for marketing. Another advantage of these cloud data lakehouses is they automatically scale. So one instant you have few users and you can get by with what they would call a compute resource, one compute resource. Then suddenly you have thousands of users or something going on. It starts impacting performance, and in a few seconds or even milliseconds, you have 2, 3, 4, a dozen of these compute resources automatically online, keeping everything running fast. Now, the combination of a data lake with fast ingestion of data and simplified administration, allowing you to easily copy and create new data warehouses, data marts, etc., backed up by performance enhancing auto scaling, make this system much more flexible. So if you have the new data source for marketing, for instance, and you can create a separate ETL process loading data to a second data warehouse, etc. You may also then stream that data into data lake side and perhaps feed some schema on read data research and analytics. And then after some more work and an approval process, perhaps some of that data may eventually get loaded into your enterprise data warehouse and available across all your standard data marts. Let's recap. These DWaaS, data lake houses, or whatever you want to call them, address the challenges faced by traditional data lakes and data warehouses, such as balancing cost versus performance, which they do by reducing hardware costs by virtue of being able to scale efficiently and shutting down resources when not needed. They reduce IT labor costs by streamlining and automating processes, in some cases eliminating server administration altogether. And they increase flexibility and agility by merging many of the best features of data lakes, such as fast data ingestion and AI and machine learning support, along with data warehouse features like data consumer-friendly transformations and modeling. They provide high concurrencies of queries and users, and ultimately they decrease BI's time to value while increasing creativity. Now you see why I'm calling these data lakehouses, since at a high level, the distinction between data warehouse and data lake is less relevant, as the system can handle both continuous data ingestion on one end while achieving near real-time data analysis for a large number of data consumers on the other end. Plus, their synergy with cloud-based integration tools, which we'll cover shortly, further eliminate the IT complexity, maintenance, and cost, and help drive a more flexible and agile end-to-end system. Okay, call it integration platform as a service, data engineering, data pipelines, data funnels, ETL or ELT processes. What we're talking about is managing the movement of data. Of course, integration occurs all over the entire landscape besides BI. But for BI, we may have cases where we're moving data from several applications into a central warehouse. In other BI cases, data may be moved into one or more data marts or BI platforms completely outside an enterprise data warehouse or lake.
Now, before we get into newer cloud integration tools, since this is an introduction, let's take a quick minute to review basic integration processes.
Let's return to our data lakehouse drawing. We have our data sources like ERP, HR, etc. Of course, the reality is your ERP system may not be a single system. There may be another application or two handling specific business processes. And the same with HR. You may have a core HR system and separate compensation and learning apps. In addition to feeding your data lakehouse, many of these apps may be integrated or connected to one another as well. You could easily have your ERP systems, for instance, feeding a custom data warehouse or database, and HR system feeding a separate data warehouse or data mart, et cetera, et cetera. The main point here is nearly every company will have unique and complex integration challenges.
Nearly all forms of data integration have some level of challenge regarding the three V's: volume, variety, velocity. With more and more data sources and destinations, the number of integration points have rapidly increased, resulting in a highly matrixed environment with data of all sizes and variety flowing in multiple directions at multiple speeds and times.
For instance, you may have a huge volume of data from your ERP system, moving data into your data lakehouse and custom database. And part of the issue with variety should be obvious, with a typical company employing dozens of applications and systems. But variety doesn't stop there. There's also a variety of types of integration. For instance, a custom database may allow direct query connection, but for many applications, you may only be able to extract data via flat files, while others may allow connecting via REST APIs. And last but not least, the velocity that data moves for systems like IoT is extremely fast, but most applications are creating data at a faster and faster pace. And the need for more recent data refreshes on the BI and analytics side requires faster integration.
The second big challenge is with data itself. Transforming it to fit a certain model with OLAP, fact dimension tables, etc., is an expensive operation that slows the BI lifecycle. And the separation of data from metadata during the replication, migration, and transformation steps of integration means we lose vital metadata information that would help engineers and analysts and data consumers speed up transformations and build analytics and reports. The lack of metadata also impacts data quality, as there's no coordinated monitoring, tracing, and feedback of data quality issues throughout that entire process. There are a lot of data integration players in one way or another. Some are classified as full-fledged iPaaS platforms, some specific to streaming or batch data pipelines or funnels, some that manage only API connections, IoT endpoints, and of course, tools and languages that let you build custom ETL or ELT. There are a few common must-haves between nearly every modern integration tool, such as pre-built connectors to many of the most popular applications like Salesforce, SAP, Workday, etc. Nearly all modern integration tools also contain AI and machine learning to automate processes like replication of schemas, data mapping, transformations, security governance, etc. And of course, scalability to handle fast data throughput and large data volumes. With far too many vendors to list, let's just take a look at a few of the more popular. And these cloud-based scalable platforms are used for multiple integration scenarios, including B2B, EDI, API management, IoT endpoints, application to application, of course, application to data warehouse or BI data marts. All platforms are capable of integrating cloud to cloud, in other words, integrating two cloud systems, but many also handle cloud to on-premise integration, where one system is cloud-based, the other on-premise, and some even handle on-premise to on-premise integration. They allow you in varying degrees to extract and load data, clean and transform data, replicate data and schemas, schedule data refreshes, and many more administrative features like visualizing the end-to-end process graphically, auto recovery of processes, triggering error notifications automatically, etc. Now, most iPaaS and data integration tools offer AI features that help with data mapping and automating several processes and tasks. Some iPaaS, like Workato, are more drag and drop, low code oriented, while others, like Boomi and Informatica, allow for more custom coding. Some, like Azure Data Factory, are vertically integrated with other vendor products and platforms, while others, like Talend, are more tech agnostic, open source oriented. There are, of course, a vast array of iPaaS and other data integration vendors that offer a unique mix of many of these features. A huge market trend for data integration is the inclusion of master data management capabilities, especially data asset and metadata management via data catalogs. So before we dive into data catalogs and why they're growing in importance, let's talk about some more basic concepts, particularly metadata.
So metadata is usually described as data about data, or said differently, information on data objects. That information may include description, size, type, and so on.
Practically every application comes with some type of metadata guide. This may take the form of a simple integration or API guide, a data dictionary. Often these are online or in Excel. Frankly, these guides often provide just basic metadata, the name of the object, the allowable size, etc., that the maker of that software is required to do. As we noted in our first video, with more and more data and data objects being produced, enterprises find it difficult to manage hundreds of thousands of individual data objects, the vast majority of which, far less than 1%, isn't needed within BI. Simple data dictionaries and homegrown guides in Excel have given way to more robust data catalogs to help manage this metadata across enterprises. Not surprisingly, data catalogs and other data governance tools are either embedded or loosely integrated with many data integration platforms. Modern data catalogs provide more complete end-to-end metadata, starting with the origin of data through any migration and transformation it may go through. The most important capabilities include, of course, listing the data object size, description, and type, object relationships, have foreign key relationship or other relationships. They track the lineage, the object origins, parent-child relationships, and any transformations along the way. Who has ownership or is the steward or subject matter expert for that data object? And finally, data catalogs can monitor data quality metrics and provide feedback to the stewards and owners to help improve overall quality.
So a closely related aspect of metadata, of course, is data quality, where metadata is defining the attributes, the size, the type. Is it a string? Is it a number? How big can it be? And that, of course, has a direct bearing on data quality.
Of course, most of us heard the phrase garbage in, garbage out. By extension, any analytical report relying on bad data becomes a bad analytical report itself and produces distrust in your BI team, and even worse, bad decisions. Now, with metadata defining important attributes, if the actual data doesn't match the metadata, then either the metadata is incorrect or you have bad data. All too often, though, the problem is metadata is non-existent or just not where you need it. It doesn't do you any good if there's a wealth of metadata, but it's often some unknown spreadsheet somewhere. And one of the best practices for ensuring data quality is where you distribute data, you also distribute and manage metadata as well, from the origin to the warehouse to the data marts to the visualization tools. And with data integration tools' central role in orchestrating data flow, empowered by embedded data catalogs, it's now easier than ever to do this. So, data catalogs, real value add for BI is to provide data scientists, integration engineers, modelers, analysts, and other data consumers with information so they can focus on the less than 1% of data objects that really matter, ignore hundreds of thousands of other objects. And so they can have better data object insight from origin and lineage, relationships, etc., to speed up transformations and the BI lifecycle. And so your BI team can play a more active role in assuring data quality. Okay, so back to how newer cloud integration tools address our main challenges. They address the 3 V's of volume, variety, and velocity by simplifying integration management across multiple data sources and destinations with machine learning augmented and automated data mapping, connection management, and much more automation. They offer scalability that can have fast streaming data as well as batch data of all sizes with AI-driven refreshes, auto recovery, etc. They handle the challenges of the data itself. They serve as a focal point for not just data management, but metadata management as well, supporting the improvement of data quality. And they support faster and easier transformations and BI development in doing so.
Let's recap what we just learned and go back to where it all started.
Undoubtedly, one of the main goals of any organization is to increase the return on investment of their business intelligence. We discussed how Cloud data lakehouses reduce hardware costs with their ability to scale, and they help control IT labor costs by automating and simplifying maintenance and admin tasks. These lakehouses can serve multiple needs: data lakes, data warehouses, specialized data marts, and a combination of all those. We also discussed cloud integration tools, how they help manage an increasingly convoluted data environment by handling data of all kinds, sizes, and speeds across data lakes, data marts, and what have you. They handle APIs and files and on-premise or cloud systems, all while offering better data insight with metadata and data catalogs. Of course, the result is both increase the time to value of your BI team, reducing the time required by data engineers, scientists, analysts, and consumers to manage data and produce analytics and reports by virtue of their flexibility, ease of use, and their capabilities. Now, in our next video, we'll cover visualizations that, coupled with modern data management, can take us one step closer to better decision making.
Okay, thanks for watching again, folks. Hope you learned something. Our next video is on modern visualization tools and their impact on BI. Hope to see you there.